Math 3, Unit 6, medians and angle bisectors. So medians and angle bisectors are different segments within triangles. The median of a triangle is the line connecting the midpoint of one side to the opposite angle or the opposite vertex. So what I'm going to do is I'm just going to estimate here. You won't be asked to construct these. I'm going to estimate some midpoints. There is a way to construct them perfectly, but we're just going to, without measuring. We are just going to eyeball it here. A median connects the midpoint to the opposite vertex. So if these are midpoints, then that means those sides are equal. These things are equal. And these are equal because it cuts it into two congruent pieces. The point of concurrency is where two or more lines intersect. It's the point where they intersect. So these all intersect at this point. The point of concurrency of the medians is called the centroid. So I'm going to label some of these points on this triangle, A, B, C. I'm going to call the centroid point D, and these midpoints E, F, and G. So the special characteristics of the centroid, or the medians, is it bisects one of the sides of the triangle. Every triangle has 3 medians. The centroid is always inside the triangle, that's important. And the centroid of a triangle is always located 2/3 of the distance from each vertex to the midpoint. So what it does, this is called the 2/3, 1/3 rule, is it cuts the median into where the bigger portion is 2/3 of the whole thing, and the smaller portion is 1/3 of the whole thing. So that gives us some equations, and I'm just going to write equations for the line AF. AD is equal to 2/3 of AF. So the bigger portion is always 2/3 of the whole thing. DF is 1/3 of AF. The smaller portion is always 1/3 of the whole thing. That means that AD is equal to times DF, or you can say that DF is 1/2 of AD. Okay, this is just for this one. This applies to all the medians when the centroid is known. Also, you can say, and I'm just going to do the one side, BF is equal to CF, AG is equal to CG, AE is equal to BE. This is just based on the properties of the medians. All right. So, given that point T is the centroid of the triangle, and AB equals BC equals 30. That means both of these sides are 30. And AC is 48. Find the following values. All right, so we have BE. We are going to use the Pythagorean theorem to find BE. Because this is an isosceles triangle, the medians are perpendicular. So the median from the tip of the same sides to the opposite side is perpendicular. That means BE is perpendicular to AC. Since these are medians, we know that CE and AE are half of 48, which is 24. So what we've got here to find BE is a right triangle. So to find BE, we can say that BE squared plus CE squared equals BC squared. So I'm going to write that formula. I'm going to write that out. So BE squared plus 24 squared equals 30 squared. In your calculator, you have 30 squared. You can subtract your 24 squared, and you get BE squared equals 324. Take the square root of both sides, and you get BE equals 18. So that's the whole thing, BE. So now we can use that to find BT. Because T is the centroid, this point here is the centroid of this triangle, BT is going to be the bigger portion, because it looks bigger, which is 2/3 of the whole thing. So BT is going to equal 2/3 of BE, which is 18. You can type that straight into your calculator, 2/3 times 18, and you get 12. TE is the smaller portion, so you could set this equation up a couple different ways. TE is 1/3 of BE, 1/3 of 18, or you can say it's half of BT, which is 12. Either way, you get 6. AT, to find AT, I'm going to use the Pythagorean theorem. Now this time I know 6 and 24, this is a right angle. So 6 squared plus 24 squared equals AT squared. Take the square root of both sides, and you get 24.7, roughly. AD is the whole thing. So what we've got here, AT is the 2/3 of AD. So AT, which is 24.7, is going to be 2/3 of AD. To undo multiplication by a fraction, you multiply both sides by the reciprocal. So 24.7 times the reciprocal of 2/3, which is 3/2, is 37.05 or 37.1. Just going to round here. So that's the whole thing. So TD is half of AT or 1/3 of AD. Either way you want to do it. TD is half of 24.7, or it's 1/3 of 37.1. I'm going to do half of 24.7, and you get 12.4 roughly. We rounded that first one, so I'm going to round this one as well. CF, FT, and CT. CF is going to equal AD because this is an isosceles triangle. So you could also do, you could still use the Pythagorean theorem to find CT and then use that to find FT, but it would be the same because this is 6 and 24 and this is 6 and 24. So CT is the same thing as AT, which is 24.7. FT is the same thing as DT because this is an isosceles triangle. This only works when it's an isosceles triangle. DT is equal to FT, which was 12.4, and CF is going to be that whole thing, AD, which is 37.1. All right. The next one, triangle ABC. So the reason we know that U is the centroid is because of the markings. Each side here is split into 2 congruent pieces. That makes CF, AD, and BE medians, which makes U the centroid. So we're given that AU is 16, that BU is 12, and that CF is 18. So we're going to start by finding UD. UD is 1/3 of AD, or half of AU, because this is a centroid and these are medians. So I'm going to say that UD is half of AU, which is 16. Half of 16 is 8. AD is the whole thing, so that's AU plus UD. We have 16 plus 8, which is 24. So AU plus UD. EU is half of BU, or it is 1/3 of BE, but we don't know BE yet. So EU is half of BU, which is 12. Half of 12 is 6. UF, so we only know all of CF, which is 18. UF is going to be 1/3 because it's the smaller portion of CF, which is 18. 18 divided by 3 is 6. CU is 2/3, so you can say it's 2/3 of 18, or you can say it's twice UF, which is 6. 2 times 6 is 12. 18 divided by 3 is 6 times 2 is 12. Either way it works out, you get 12. And then BE is the whole thing, which is 12 plus EU, which we said was 6. 12 plus 6 is 18. The next one, CDE, U is the centroid, UK is 12, EM is 21, and UD is 9 on each measure. All right, so CU, if UK is 12, CU is the bigger portion, so it's going to be twice that UK because this is 2/3, this is 1/3. So CU is going to be twice that 12, which is 24. MU, we know that EM is 21, that's the whole thing. MU is 1/3 because it's the smaller portion of the 21, which is 7. JU is half of that bigger portion, UD, half of 9, which is 4.5. EU is 2/3 of the whole thing EM, which is 21, or you can say it is twice UM, which is 7. Either way, you get 14. CK, so UK is 12, CU is 24, CK is the whole thing, so 24 plus 12 is 36. And then JD, we have JU is 4.5, UD is 9, 4.5 plus 9 is 13.5. We're going to do some algebraic expressions here. Find each segment, or assume each segment within the triangle shown are medians. So these are all medians. Find ZQ if ZD is 6. So if ZD is 6, ZQ is going to be 2/3 because it's the bigger portion of ZD. So we're saying ZQ is 2/3 of 6, which when you plug into your calculator, you get 4. 13, DH, if BH is 4.5, DH is a smaller portion, so it's 1/3 of the whole thing, which is BH. DH is going to be 1/3 of 4.5. Plug that into your calculator, and you get 1.5. IF is a median, so find X if GE, which is the whole thing, is 3x plus 5, and IE is x plus 6. So if that's the case, then this is cut into 2 congruent pieces, or IE is half of GE. So I'm going to plug these in here. I have x plus 6 is going to be half of 3x plus 5. Distribute my 1/2, x plus 6 equals 3 over 2x plus 5 over 2. Get my x's together, subtract x from both sides. 6 equals 1/2 x plus 5/2. Subtract 5/2 from both sides. And you get 6 minus 5 over 2, which is 3.5, equals 0.5x. Divide both sides by 0.5. And you get x equals 7. And then the last one, find x if ET, which is this portion, is 3x plus 2, and EM is 5x. ET is going to equal 2/3 because it's the bigger portion of the whole thing, which is EM. So I have 3x plus 2 equals 2/3 times 5x. 3x plus 2, when I multiply those together, is 10/3 x. Subtract 3x from both sides. You get 2 equals 1/3 x. Undo multiplication by a fraction, multiply both sides by the reciprocal, and you get x equals 6. The last special segment we're going to look at today is the angle bisector of a triangle. I'm going to skip the how to bisect this and how to do it because you don't need to know how to do it. You just need to know what it means. The angle bisector is the line segment that divides an angle of a triangle into two congruent angles. And the end center is the point of concurrency of the angle bisectors. The end center, it's always inside the triangle. Every triangle has 3 angle bisectors, and any point of the bisector is equidistant from the sides of the angle. So when you do it like this, this is what it looks like whenever you actually do it correctly. Bisecting the angles, the end center is the center of the circle that can be inscribed into the triangle. So the end center is the center of the circle. That can be inscribed in the triangle. End center, inscribed. It's a circle inside, the biggest circle that will fit inside your triangle and touch all 3 sides. So when it does that, then this is equidistant. All of these radii are the same. So given that, point P is the end center of the triangle. Angle Q, so that's the whole angle Q, is 73.7 degrees. LM is 5.25. RQ is equal to RP is 25, so these guys are 25. We said LM was 5.25. And it says that QP is 4. So NP, because this is an isosceles triangle, the angle bisector bisects this side only because it's isosceles. So NP equals QN. So NP is going to be half of that, which is 7. RN is this whole side here. So we can use the Pythagorean theorem, and this triangle, right there, to find Rn. Rn squared plus 7 squared is going to equal 25 squared. So in my calculator, I'm going to say 25 squared minus 7 squared. And take the square root of both sides, solving that equation, you get Rn is 24. LP, you can do the same thing with your Pythagorean theorem. Now, before you can do that, you need to know Ln. The end center is equidistant from all three sides, so this is 5.25 as well. So LP is going to equal 5.25 squared plus 7 squared. And then take the square root of that, and I'm going to round that to 8.8. Or I'm just going to put 8.75. That's LP. OP, now I can use the Pythagorean theorem to find that as well, because this side is 5.25. The end center is equidistant from all sides. So OP squared plus 5.25 squared is going to equal the 8.75 squared. So in my calculator, 8.75 squared minus my 5.25 squared. Take the square root of my answer. You get 7. OP is 7. LR. So if this is 7, then OR is 20 minus 7, which is 18. We can find LR using the Pythagorean theorem. 18 squared plus 5.25 squared is going to equal LR squared. Take the square root, 18.75. OR we just said was 18. And angle NQL is this angle here. If the angle Q is 73.7 and these are all angle bisectors, then we just split that in half. So 73.7 divided by 2 is 36.85 degrees. Just a few more with angle bisectors. We have, in each figure, the triangle is shown with one of its angle bisectors. The measure of angle SUT is 34. Find the measure of angle 1. So that's going to be half of that. 34 divided by 2 is 17. This one, find x if the measure of angle 2 is 4x plus 5 and the measure of angle 1 is 5x minus 2. If this is an angle bisector, then these are equal to each other. So 4x plus 5 equals 5x minus 2. Solve that. Try to get your x's together. Get your constants together. Get x equals 7. In each figure, P is the end center of the triangle. So if PT is 3, then PU also has to be 3 because the end center is equidistant from the sides. Here we have PY is 2, HP is 3, find HY. So what we've got is another right triangle here. We have 2, 3, and then, oh, I'm sorry, 3 is the hypotenuse. We need to find this here. So we have x squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. Subtract 4. X squared equals 5. Take the square root. The square root of 5 in your calculator. 2.2. And then the last one. Find PB if UC is 2 and UP is 3. So this is the same sort of situation. PB is going to be equal to CP, so I can find it using CP. I've got this right triangle here. CP is my x, 2 and 3. It's actually going to be the same math we just had. We have 2 squared plus x squared equals 3 squared. 4 plus x squared equals 9. X squared equals 5. Take the square root of both sides and you get 2.2 again.